Thanks for having me, and thanks for coming, actually, with this nice weather on the outside. Event sourcing, you're doing it wrong, and I wonder why, because it's pretty easy. I've been developing event-sourced systems for a couple of years now, and I actually wanted to use this title, Event Sourcing, You're Doing It Wrong, because I know best, because being a consultant, I know best. But actually, the more I read about this topic and the more I work about this, I realize I'm the Jon Snow of event sourcing. And I'd rather use this title, Event Sourcing, you are maybe doing parts of it wrong because we made some mistakes along the way, and so will you. I guess this is difficult because there are no easy right-wrong answers, only trade-offs. But try pitching that to a conference. You will get rejected. So let's settle on the last title. Event Sourcing, you're probably doing parts of it wrong. Can we all agree on that? I guess so. So who am I? Is there somebody here from Germany? A couple. So you might, if you know football, you might know the stadium. I'm David. I'm from Düsseldorf in Germany. Big soccer and football fan, as you might see. I work for Zenacor Technologies as a principal engineer, which basically means architect, developer, something like this, in the financial industry. And if you want to connect, reach out to me via König Hotze, give feedback about this talk, whatever. Spam me on PS4 if you want to play FIFA. Yeah, so that's me. Who are you? Keep your hands up, please. Are you building microservices? I mean in production, not just Hello World with Visual Basic. Okay, great. Keep the hands up. Keep them up. Are you applying domain-driven design? Okay, nice. Are you applying event sourcing already? So the hands drop. So there are a couple of people here. Last but not least, are you using Kafka as an event store? Yeah, there's one or two. Okay, I would like to talk to you afterwards because I have my reservations. So what we're going to talk about is typical misconceptions, because event sourcing is like a quasi-mythical approach to doing microservices or whatever, handling data, and I want to get that slate clean. We will discuss some patterns that we found useful in our concrete projects. I won't do any theoretical work here. We are looking at concrete examples. We'll look at traps you might want to avoid. This is not a Kafka rant. If you know me personally, you know I tend to rant a lot about every other tool, and this is not intended as a Kafka rant. We will compare to Kafka in certain places because Kafka is quite popular today. And keep in mind, and this goes for all the talks at this conference and at every conference, those are not silver bullets. You always have to include the context of the speaker. I do not try to sell you any silver bullets, so use your own mind and head. Since we only have 50 minutes, we only cover the tip of the iceberg. If you want to know more, as I said, reach out. I'm available. I saw that some of you are already doing event sourcing. Nevertheless, for the rest of you, we have to do some boot camping here. And the first thing you have to realize, it's not about event sourcing. It's about your business. It's about your domain. It's basically about the event-driven business. And every business is event-driven. Non-event-driven businesses, maybe they exist. I haven't seen them. Typical example, let's say we go to some coffee shop and we want to have some coffee. So at the point when we ordered a coffee, a new fact appears. Coffee ordered. David has ordered a coffee. Then there might be another fact. After I've paid my coffee, there is an event called order paid. And last but not least, there's coffee prepared. All these are basically intrinsic to that domain, and you will find that in the financial domain, you will find that for video games, you will find it everywhere. So what's the advantage here? The advantage is by using these facts and events, mainly stating things have happened, we can make the dynamics of our systems explicit as first-class citizens. That means we are not talking about data, we are talking about things that happened and why they happened and in which context and with which data. That's the combination. Sounds cool. What about technical level? I already told you I'm an architect also, so I go to my customers, large banks, financial industry, insurance companies. And what's the primary tool of an architect? Is it Java? Is it Kotlin? No, it's PowerPoint, of course. So what we're drawing is boxes with microservices. And the question arises, how can we represent this data I was talking about, and how can we represent this dynamic feature, coffee ordered? How do we represent that? And in general, the discussions like this, we introduce something that's called a golden source of truth. Think Kafka. And then the microservices send some events, they receive some events, have a local database, and Yeah, let's put in a data lake for good measure because we need it. Who has a data lake in this company? Nobody, seriously. There's always one poor soul. And that's actually where the discussion stops. The rest is magic. Just do the right thing. And this little guy will be our companion here. That's the silver bullet magician. Just use magic. Can we approach this differently? Yes, we can. First of all, what is an event? I've already said, events are facts. Like in this case, user onboarded. We store those events and those facts in something that is called a stream. Like in this case, a user David streams with the events of David. When we store those streams on a physical level, like think database, that is called an event store. An event store can be the product event store, but it can also be a MongoDB, a MySQL database, I don't care. Now we have those streams, and we want to answer the question like, get the current David. That's something that we call a projection. Basically, we look at a stream, we interpret those facts, and then we end up with something that's called an aggregate. And please note, once again, it's the David at a certain time in our system. It's not the David, because the David doesn't exist. I exist, but not, you know what I mean. And once we want to store that thing, we can use a regular database like a Postgres, and that's called a read model. In other words, we have the streams. Streams contain events ordered in the direction of time. Each event has its payload. And projections are basically a definition of handlers. How do we want to interpret those different events? How do we want to handle user-created, and so on and so forth? And then we end up with the aggregate, which is state at a certain point of time. There's actually nothing more to talk about in event sourcing. That's basically everything. So we are going to talk about read models. We are going to talk about transactions without having transactions. We are talking about versioning and changing things, which might happen in a software system. We will talk about dealing with errors and how can we correct state, although facts are not changeable. And last but not least, at least as a German, my favorite topic, GDPR and compliance. We love that stuff. So this is a read model. And when you start reading about or working on event sourcing, the first thing you always find is read models. And I will tell you, if there's one thing that you remember from this talk is try to avoid read models. You might not need them. Going back to what we saw before, the stream. We aggregate all these different events, and we end up with the user aggregate. The fact is, when we have many, many events, and we apply all these events onto each other, this can take time, right? This is expensive. So we might want to store those representations somewhere. And what's the common solution? Well, just use a database. What could go wrong? It works like this. We have our user microservice that is responsible for user events, and we use some lightweight database, maybe Oracle SQL Server or something in that vein. And the idea is we create a table. And that table, as you can see, contains the user ID and the last event that we read and whatever payload was included in those events. And when a new event arises, then we can just update that representation in the database. Easy, right? And the coolest part is, and you always read that, no? With event sourcing. Let's say we don't want an SQL server, we want something graph database-like. Then we can just drop the SQL database and rebuild everything from scratch. Easy. Well, maybe not. Just think about the fact that you have an SQL server or a SQL database and the event store itself and the events itself. Different data sources, so you will have eventual consistency. You cannot guarantee consistency in that place. And I just mentioned you can throw the database away and rebuild it from scratch. Try to do that in production without downtime. You will have fun for weeks. And I saw this article that somehow some vendors have solved the problem with exactly once delivery. Well, if you want to ensure that a message gets delivered once and once only, this is fun. There are people that have written their thesis on that topic. And last but not least, a simple technical reason, think about operational complexity. My colleagues really love when I introduced new databases on a daily business. They love doing backups and stuff like this. Well, turns out you can just forget everything about read models, at least at this stage, and you do not use it. And it depends on how we want to store our events. You might know the typical description, like in this case, how we want to apply event sourcing, and we have a user topic, and that thing just collects all the different events from all the different users, like in this case, user A, B, C, and D. And just imagine if I want to read everything that belongs to user A, I have to go through all these events, look at that thing, see, it's user B, don't read it, it's user C, don't read it, it's user A, I can use this. In this case, it's not a problem, but I imagine your systems, there are more customers than 4. There might be 40 million, I don't know what you're doing, but obviously that doesn't scale. A better approach is rather simple. We split that thing up, and every aggregate gets its own stream. There's a David stream, there's a Hans stream, there's a Holger stream, there's a Stephanie stream. Every customer has his or her own stream. And the cool thing is, just look at that thing. Now only 4 events, or 10, maybe 20, but not 40 million or 60 million. Tiny streams. That means when we try to read user B in this example, yes, JavaScript, I'm really sorry, shame on me. We only have to declare the handlers, like in this case, what do we want to do when a user-created event appears for each event type, and then we read the whole stream each time. We declare which stream, and we use those handlers. That means every time I want to read user B, I read all 4 events, every time. So there is no other data store. The event store is physically the golden source. There's no way around it. You don't have any operational overload with your DBAs or databases. And the programming logic, which I show you, is exactly that. There's no framework, there's no magic. You just read one event after another and apply it. But what about speed? Well, turns out that most event handlers in your system will be what? Getters and setters. Yeah? Set address to some new value, set name to some new value. So actually reading the whole stream from beginning to end is not an issue, mostly, if you design your system correctly. So I don't worry about that. If I come to that place and that thing is the bottleneck, then I can introduce a read model. But what about queries? Let's say we have a user stream for you, we have a user stream for you, and so on. How can I find every attendee older than 25? How can we do something like this in a SQL language? Select all the users with an age greater or equal to 18. In that case, remember, we had the projections. We built projections. And it's the same thing. We have an adult user projection which basically goes across all the different streams and gathers all the data from different streams that represent adult users. It's a piece of logic, exactly. In real life, at different customers, those projections are actually microservices themselves that represent that single query. So keep in mind when you talk about read models that your handlers are mostly, I would say mostly, trivial, getters and setters, nothing else. If your handlers are more complex, then that indicates that you're using command sourcing, I guess, that you're doing more complex things, different beast. Design your aggregates that they are small, like a user, a bank account, a financial institute, something like this, maybe a coffee order. And measure first before you introduce any crazy databases, because databases are fun. Now we know how we want to actually design our streams. We keep them small, everything in its own distinct bucket. But I really like correctness. You know, working in the financial industry, I really like bank accounts to be somewhat consistent, which is a lie. They are not consistent, but different story. The first thing you have to realize is a trivial thing, that the outcome of any business operation depends on the order of events. Let's take an example. Let's say we have a business rule that says you can only withdraw money from your account if your account holds enough money. You know, if you don't have money, you can't withdraw. That said, banks do not operate that way. They really like when you overdraw your account because that way they earn money. So here's the example. Let's say we deposit money, 100 euros, then we withdraw money, we end up with 90 euros. We withdraw again, -7. Violation of our business constraint, so we avoid that event. And last but not least, we deposit again and we end up with 140 euros. And if we shuffle those last 2 events, we end up with something different. We deposited money and we can withdraw, so we end up with 43. So just changing 2 events in that sequence, different outcome. And in domain-driven design, we say that the aggregate is responsible for those business invariants, these business rules. Kind of meaty. It's actually a simple concept. Let's say we have an account, and the account is the business aggregate here, and it holds 30 euros. And there's a new event, money withdrawn, and it wants to withdraw 50 euros. And then you can imagine those business rules as basically a police officer says, no, can't enter. I reject you. So basically, if you think transactionally, the aggregate is basically guaranteeing the transaction. But we don't have any transactions, right? It's not a database. What can we do? Well, we can put a database in front of the event store for handling those transactions, right? Well, maybe not. Who is building systems that are single-threaded? And I'm not speaking about Node level, Node.js level, single-threaded. I mean, there's one person, two person, yeah? Okay. No concurrency, no event handling in the background. It's a different story. My systems are mostly parallel. Like in this case, we have two instances of a microservice account, and they use their read model. And the first service checks if there's enough money, sure. Second account checks if there's enough money, sure. And both try to withdraw at the same time. And the account basically just goes up in flames. That's how I imagine bank works. So if we validate against read models, against these other data stores, then we will run into those inconsistencies. There's no way around it. Well, there is. Being a little bit older than most of you, I guess, there's something fun from back in the days that's called two-phase commit, distributed transactions. Who remembers that fun? Yeah, I feel you. No, of course, I'm not just joking. But what's a serious answer here is we can manage transactions with a database and use something that's called a single writer. That's a great blog post from our colleagues at Confluent describing putting a couch base in front of Kafka and then using basically that couch base to funnel all the different things that happen in your system one after another. And yeah, let's just stop there because I have a quick tip for finding new friends in operations. Ask them to maintain that thing on AWS. Couchbase and Kafka, production grade. You won't be invited for dinner, I can tell you that. There's another answer which we can use. Who's using Hibernate or JPA? Yeah, I guess 2/3 maybe. And there's something really old. It's basically optimistic concurrency control. It's not a new concept. The idea is that when things happen in our systems, chances are that they don't impact the same aggregate. That means if somebody is working on my file in the system, then she won't be working on your file, but she won't be having a colleague that's also working on my file. That means multiple things can happen at the same time without interfering. And before I update your state, I check if that state is still the same. Nobody has messed around in the back end. Let's look at an example, the happy path. Once again, we have an account, and now you can see there's money deposited with an event number 5. And then we want to do something. We build the aggregate like before, and we remember that last event number that we read. It's basically just the number of that event. And then we try to withdraw money, but before appending that to the stream, we compare those numbers. And if those numbers match up, nobody has messed around with the stream, and we can add the sorry, that's what you get from using animations and having sausage fingers. And then we can append the new event, and you see the new event number 6. Easy peasy. What if somebody messes around? Let's say here in this case, once again we read the aggregate, we remember the event number, it's number 4 in this case, and somebody else updates the stream. And you can see now it's a new event with a number 5 at the end. And then we compare those numbers. Once again, before withdrawing money, and we see 4 is not equal to 5. Crazy. And then we rejected that event. No magic involved, no frameworks, nothing. On the programming side, let's say we want to update an account. It's pretty much the same like before, only in this case, we remember the last version number, we execute the business logic in case, and when we emit those new events to the stream, we pass along the last version number. And everything else is handled by the event store. Matches up. And that's basically optimistic concurrency control. Yeah, can we do that with Kafka? There's a nice ticket that's still open. I've checked before coming here. Kafka 2260. It's basically about allowing to set an offset when producing new events. And actually, I think they won't be working on that thing because the discussion is like they will replace it with something else. And like this person mentioned that it would be very handy for event source systems and would be great for event sourcing, la la la. But I guess we can't count on this thing being implemented as it is minor, unassigned, and still open. So I guess we have to implement this couch-based thing. So with OCC, with optimistic concurrency control, you get scalability without any locks, without any infrastructure, nothing. We get consistent write, and we can decide when we want to use it. It might be for some things that are just signals, where concurrency or consistency is of no concern, then we don't use it, we just append. But in things where we want to have consistency, like a bank account, for example, then we can use it. And the programming logic is exactly as shown. There is no magic, no framework, nothing. So now it's the fun part. We know how to write, we know how to read, we are done. Most of the time, my systems are going through some form of change. That means new requirements. And being Java developers, we have a great answer for how we can deal with versions without going crazy, right? There's one single magic bullet that we can use, namely semantic versioning, right? Everybody loves that. And typed events, of course, because types are great. How does it work? We have a producer that produces different events like account opened and money deposited. And being good developers, we create jar files for easy sharing of those event types. And consumers read those streams and they can reuse those events. And then we change something. We know how to do that. There's a money deposited version too. We store it also in a jar file. But our consumers are still stuck on the old version. What happens? What happens is fun. Typically in production, there's an invalid class exception, everything blows up, you get fired, and sad things will happen. And then you will find another solution that's called double write, also magic. Basically, the idea is we produce both versions, the old and the new version. Money deposited version 1 and 2. But that's a problem for the consumer. What can that thing do? Can it process the version 1? Or does it have to wait for version 2, which might or might not arrive, or other way around? And just think about the handlers, all the different handlers for different versions. I like writing this stuff. It's easy, you can do it with a hangover, no thinking, just writing handlers. Well, there are frameworks like, what's it called, Action? And they have something that's called an upcaster, which is basically a pretty nifty idea. You put the upcaster between the streams and the consumer, and that thing is able to convert old messages in the V1 format to the V2 format, and the consumer only has to deal with a certain version, which kind of works, kind of. And then 5 months later, that thing actually knows everything. It's basically just a giant mapping table. I tend not to maintain those things, so good luck maintaining the thing. The point that you have to understand is when you introduce incompatible changes to events, then that is not the same event anymore, that's something else. It's like when you talk to people that are about API versioning, where they have a V1 and V2 in the API, in the URL. From my perspective, needs to be discussed because that typically indicates something new. It's a new service, it's not a version service, it's something new with a new different name. So in general, event changes have to be compatible. There's no way around it, or introduce new events. And speaking of events, I said types are super, but we found that actual simple text-based human-readable events work best. And that's fancy speak for JSON. Yep, JSON. Guilty. You can use YAML if you want, but we use JSON. So how does it work? That's basically a representation of an event. We have the event type, we have the aggregate ID, we have the account number and whatever, and the currency and the amount. There's some metadata usually, but in general, that's that, nothing else. But correctness, we don't have types. How can we go on and say what's correct and what's not? Well, even there, the answer is, if your system is long-running and long-living, actually stringly typed events work best. If you introduce some arbitrary type in your system and I have to consume that thing, I'm for always bound to your definition of a certain type. Just use text and let the consumer decide. If you want, you can introduce something that's called a weak schema, something like JSON schema, which might be familiar to you or not. Basically, you are able to declare the event type and what it does, some description. You can describe the payload, like in this case, user ID with some UUID, and so on. And then upon publishing those events, we make sure that the published event actually conforms to that schema. The publisher is responsible for that, not the consumer. The consumer has to accept whatever is sent to him or her. It's basically like a MongoDB. You know, when Mongo first arrived, everybody was like, hey, it's NoSQL, so we don't have any schemas. Of course there are schemas, just in the application. Not anymore on the database level, it's in your application. When you read a document, then you have to decide what you expect. Same with events, schema on read. Okay, so we have our events, we have our payload, it's JSON. JSON is basically everywhere, so can be reuse event data. Concrete example from our projects, we have a transaction ledger. Basically, let's say whatever happens on your account, what your income is, what your outcome is. And there's a different microservice that's responsible for the visualization. Basically, what happens is we have some transaction booked events, and on the other hand, transaction tagged. Like you spend 50 euros per month on bottled water, something like this. Well, if we want to do that, there's a general advice that you can copy event data around the place because it's convenient. Here's the example. We have transaction booked, and our tagged event also needs the amount and the currency because we want to visualize everything. But as things and requirements change. So the budget planner at one time in the future said, I want to have the transaction purpose also so that the user can drill down. The purpose was on the original booking event, but the tagged event misses that information. This is called a lossy event. You introduced a fact, and by that fact, you are losing information. You wouldn't do that in general database design. So why do it here? Reference across aggregates only using the aggregate ID and the event ID. So basically, in this case, instead of copying the data around, we only reference the original event using the TX booked event ID and the transaction ID. And then we can introduce something that's called a domain service. That thing is able to look into the transaction tags and the transaction booked and build up something that's used for the budget planner. You can see it contains everything, the category, the transaction ID, amount, currency, everything. And this thing is a good example for using a read model because reports are always inconsistent, are eventually consistent. So that thing is good as a read model. So just keep in mind, don't copy parts of an event, rather build those projections. I've said that streams tend to be small if you design your aggregates in a sensible way. But the question always comes like, in my bank account, there are many, many transactions over a year. So how do I handle large streams? How do you handle event data over a long period of time? Turns out you don't, actually. And the solution is, and here he's pretty much right, the little wizard, we create snapshots. Not useful advice, but it's actually what we are doing. And it's called year's end procedure. Who works in a company with an accounting team? Nobody, everybody's asleep. That's the perk of having a talk after lunch. So that's called year's end procedure. It's basically just an accounting practice. That means they execute some specific operations to close a book on a time frame. You might have heard that from your boss. We have to close our books on 2017 or something like this. And the same is for event sourcing. Everything I tell you is known to your accountant. Basically, it's called copy transform. It's the event sourcing refactoring power tool in my books. Let's say we have this large transaction ledger from 2017 with many transfers, and then there's 2018. What we can do is we aggregate the state, like my account holds 50 euro at the 1st of January, then we deactivate the original stream, we link those up, and then we can start using a new stream. There's nothing more to it, actually. The important part is we never delete the old data, because at one point we might want to have a report across all the years, and then we need this old data. And from the microservices, the same thing. Once those initialization and deactivation events appear, that thing can just switch over. I use the terms just. Remember doing the switch in runtime without any downtime, it's a different talk actually. It's a workshop for 4 months or something like this. So that's not that easy, but it's the general idea. And it's the same idea if you want to remodel your domain. When I go to my customers, I always find something like the foo and bar event. Something happened and something else happened. And that's always a modeling mistake. It's like in this case, we have transferred and booked. It's a modeling mistake, nothing else. So we can use copy transform here same way. So we initialize the new stream, we put the data to the new stream, and when this thing happens, we split it up into 2 different events and we have refactored our streams. Easy as it is. The devil is in the details. If you want to know how to do that in runtime without downtime, come to me. I can give you some insights there, but it would be too much for this talk now. So we can deal with modeling errors, but how can we deal with errors in our events themselves? A fact, like in this case, we didn't use the currency, we used some arbitrary other stuff. Well, depending on what you're using as an event store, you can just update the event store. Like in this case, update transactions, easy. Well, maybe not. Actually, for consumers, that's really the worst case. The consumer might have read all these events, and then you update some previous event. And the consumer, I know that event, I don't read it again, so why should I? So I just ignore it. And then you will find something that's called compensation events. Who is old enough to still know WS transactions? Web services, you know they had those compensation events too and they never worked. Actually, ignore that and go to your accountant and she will tell you use something that's called a cancelled or corrected booking, or in this case, event. And there's something that's called a partial compensation. Like in this case, we have money transferred with the invalid payload, and then we emit an amount corrected event. And you can see the amount now is correctly using a currency. In fact, I do not use this partial compensation. I always use full compensation. Why? If I transfer money to you and I use a wrong bank account number, the bank won't correct the bank account number. It will cancel the transfer of money, and I have to reissue a new transfer. The same thing here. Money transferred, wrong currency, so we cancel that transfer and we emit a new fresh event. Please note that we keep the reason event ID so that we can basically refer across the different events what happened. So the full compensation is basically a measure to make compensations explicit. A partial compensation, on the other hand, is not explicit. When I look at a stream with partial compensations, I always have to use my brain, what went on and where am I and what happens next. So full compensations. GDPR compliance and event sourcing. GDPR is actually called the Regulation 2016/679 of the European Parliament and of the Council of 27 of April 2016 on the protection of natural persons with regard. I will stick to GDPR if that's okay for you. Although I really like the German term, Datenschutzgrundverordnung. It doesn't get any more like Bratwurst, it doesn't get any more German. Basically, I've read that document, it's terrible, and there's one article that's relevant to this discussion. It's basically the right to be forgotten. You might know that from your company or other companies on Facebook. You can write them a letter and tell them, please delete all the data that actually is personal identifiable for myself, so my data. And how can we do that in an event source system where we cannot easily delete things? There's a recommendation like this. Encrypt the streams and throw the key away. How does it work? We have the different streams. Each stream gets its own encryption key. We encrypt the data, basically. And if a user comes along and says, please delete all my data, we basically delete that key. Like in this case, we get rid of the yellow key, and then we cannot access the data anymore. What could go wrong? Well, there are some challenges, actually. First of all, who has worked with a key tool that's actually fun to use? I haven't seen one. So key administration, how to delete keys, how to create new keys, it's kind of a pain in the neck. And then finding what needs to be deleted, it's kind of a hassle if everything is encrypted, because at one point you have to have all the keys, which doesn't work. And think about the storage implications. We never actually free data It's just data, 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 and it gets aggregated, and it's still lying around. Streams are there. And of course, yeah, we have S3, so we have limitless storage, but in the end, the more data you store, the slower your database will get at one point in the future. And last but not least, the thing that's most important to me is the coding complexity. Encrypting data, decrypting data, without using big frameworks is still difficult, it's still error prone. So if we can avoid that, I'm all for it. And now, last but not least, think about your colleagues in operations. If you want to, for example, look what went wrong with your data, you might be able to look into that stream, and if it's encrypted, what then? Turns out the SQL guys were right. Being able to delete is awesome. And we can actually do that using event sourcing, basically with tombstones. Again, the example, please delete everything from user 456. Let's say we have 3 microservices: user, bank account, and the famous transaction ledger. The idea is we delete the user and signal that to the other microservices. The bank account, in turn, can look which data belongs to that user and delete its data. Like in this case, bank account deleted, and vice versa for the transaction ledger. So basically, we handle the deletion of a user the same as any other fact. Using the event store, we basically tell the event store, delete that stream, because all the data of that user is in that stream. We don't have to look anywhere else. So we delete that stream. Event store physically deletes that stream and emits this tombstone event. As I said, the bank account in turn can do the same thing, delete the bank account. We delete the stream physically, it's gone from the hard drive, and we emit the tombstone. Easy. But what about dependencies? Basically, if I transfer my money to you, there must be some record that I actually did that. I cannot just delete my account and nobody knows where the money came from. It doesn't work. There's a thing where we just anonymize data. And I can only refer to Recital 26, which explicitly states that anonymization is not anonymization if it can be used to basically backtrack to you. It's no difference for the system if I use your first and last name or I use a UUID. If I can basically match that UUID to you, it's not anonymous. The basic question is, what happens if you, for example, delete an account in Confluence, the wiki, Confluence? Does Confluence delete all the pages that you created? I hope not, because that would be terrible. No, what it does is basically it deletes all personal data, but it keeps this nice photograph of a gray person and calls you anonymous. And that's something that we call the public-private split. And it works like this. Instead of having one stream for the aggregate user, we have 2 streams. User public and user private. And you can see a user private contains my last name, my first name, and the license plate, and that's not my license plate. And the public stream contains arbitrary stuff like some ID and my favorite color. And turns out we can keep the public data in most cases and just get rid of the private data. That way we can keep the references across the aggregates. So you may be able to keep those public data points. Why do I say maybe? Because there are no easy answers here. You have to ask your lawyer and CISO. They are there for a reason, actually. So no talk is complete without a cat picture. So that's it. Yeah, kind of. Microservices and domain-driven design and event sourcing fit perfectly. So I really struggle to imagine how one does event sourcing without domain-driven design. So if you are doing that, yeah, let me know. I'm always eager to learn. Who's not working in some kind of agile methodology, like using some waterfall crap? Okay, most of you are doing agile now, so great. That said, event sourcing needs more upfront design. You have to use your brain before starting your work. You have to find time in your 2-week sprints to actually go into the depths and do upfront design. Yeah, I know upfront design, terrible. But you can refactor, you can clean up. It's just not that easy like in classical systems. What you will find is there are not enough books. If you try to find books, they're mostly technical manuals doing event streaming with product ABC, but not about the method. How do I design my aggregates? So stuff like this. So there's a lack of literature there. Being a polyglot developer, my systems are in Lua, Python, whatever gets the job done actually. I tend to avoid frameworks I like libraries. I like Log4j actually, but I really am not a big fan of introducing heavyweight libraries that bind me to some vendor forever, because then if I switch to Node.js, I have to find a new framework for that thing. So I tend to avoid framework lock-in in that case. And event sourcing frameworks are super locking in. And be careful when somebody says something like, you have just to do things like this and blah, 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 made easy. You only have to do this magic formula and your problems will go away. Never works. So waste of time actually for you. Forget this talk. It should have said that in advance. Because do the same thing as I do. Read some papers. Like in this case, event sourcing and CQRS journey. It's a little dated paper. It's publicly available. It's a little dated, but it explains nicely how you get from one monolithic application to an event source and CQRS system. Then there is this book from Von Vernon about implementing domain-driven design, especially about aggregate design. And yes, I'm a heretic. I recommend his book and not the blue book from Eric Evans, because that thing is actually readable. But that might be my problem. Then there's this great series of paper about the dark side of event sourcing. I mentioned refactoring your stream in runtime without downtime. They explain how. It's kind of theoretical, but it's quite interesting. And last but not least, there's this book from Greg Young about versioning event source systems. It's available on LeanPub. So LeanPub basically puts parts of whatever it earns to some charity, so it's a good thing. I mentioned choosing the right tool because I tend not to build those systems anymore from ground up. I can refer you to eventstore.org. It's basically an open source project. It's basically the event store that's written for event sourcing from the ground up. So everything like optimistic concurrency control, highly scalable reads of events, it's implemented in that thing. That said, one word of warning, the documentation is super crap. You will die when reading that thing because they confuse you all around the places. But the Google group is super helpful, and the community is also quite nice. So definitely check that one out because I think it's underestimated. And that's already it. Thank you. Questions? You get a free T-shirt if you have questions. No T-shirts. Just lying. Well, look, there's one question behind you.
Have you been using some other database than the event store for event storing?
Yep.
Is anything worth being recommended?
The question was if we have used anything else but event store for that kind of thing. And indeed, first of all, we have built our systems ourselves using MongoDB. It kind of works. It's quite easy because the representation fits nicely. You know what I mean? You can do one aggregate as a document. And there's something that's called serialized I/O. It's basically an event store in the cloud. I've played around with it a little, but I haven't used it in production for anything. So don't take my word for it. But there are a couple of event store products out there. Just Google it. We have used event store on multiple projects now, and in the financial industry, and we are super happy with it. So yes to both. No other question? Then thank you and have a nice day.